Welcome dear students. This is part 1 of vector. In part 1 of vector we are dealing with scalar product or dot product. You might know that dot product is scalar and cross product is vector. So here we are dealing with dot product or scalar product in part 1 and cross product or vector product we will do it in part 2. So this is a vital video for classes 11 and 12, whether it is ISC or CBSC or any state board higher secondary exam. Scalar dot product of vectors in part 1, vector multiplication dot product. Now once again we repeat that dot product will give you a scalar quantity and cross product will give you a vector quantity. Now see the example given below. A vector, why it is a vector? We have put an arrow on the top of A. B vector, again we have put an arrow on the top of it. So A and B are vectors, but when you multiply, that is dot product, the result AB does not have an arrow because it is scalar. A was a vector, B was a vector, and they had arrowheads, but after multiplication AB does not have any arrowhead because it is no longer a vector. So AB will be just a number. So A was a vector, B was a vector. After multiplying the dot product, AB does not have any arrow because AB is scalar. So dot product means the product will be scalar. Cross product means the result will be a vector. So here we are dealing with dot product. So again we repeat, the arrowhead will be on individual vectors, but after multiplying the dot product will not have any arrow. It will simply be a number without any direction, so no arrowhead. Now when writing vector you can write in two ways. Either you can write simply the numbers separated by commas, like we have shown -6, 8, 10, or you can write -6i plus 8j plus 10k. So either you can write I, j, k, or simply you can write the numbers separated by commas. So -6, 8, 10 means -6i plus 8j plus 10k. So a vector may be written in any of the two ways. Now here, what is the absolute magnitude of a vector? We are not multiplying. There is only one vector. We have not multiplied yet. We will come to the dot product later. Just how to find the magnitude of a single vector. So either you can write as -6, 8, 10 or -6i plus 8j plus 10k. The magnitude will be denoted as A between two vertical bars. Vertical bar, A vertical bar. And the absolute magnitude will be given by the square root of the sum of squares. So square root of -6 whole square plus 8 whole square plus 10 whole square. So square all the numbers and then find the square root. So -6 whole square is 36, 8 square is 64, 10 square is 100, and we are getting square root of 200 or 10 root 2. Now this is an absolute magnitude, so it does not have I, j or k, or it does not have direction. This is just the absolute magnitude without any direction. So square all the numbers or all the numbers associated with I, j and k, add them and find the square root. So that would be the absolute magnitude of a single vector. Now we will multiply two vectors. So vector A, since I have written the word vector, I have not put the arrow, but if you do not write the word vector, then you will have to put the arrow on top of A. So vector A is 3, 4, 5 or 3i plus 4j plus 5k, and vector B is -6, 8, 10, that is -6i plus 8j plus 10k, Now we have to find the scalar or dot product. So write down the way in which I have shown 3, 4, 5. That is, I put the sign so as not to get confused. Plus 3, plus 4, plus 5, and bottom minus 6, plus 8, plus 10. So arrange them, the numbers, in this way, and then we will multiply. So let us see how to find the dot product of two vectors. So now we proceed to multiply the vectors dot product. So we have written plus 3 plus 4 plus 5, that is for A vector, and for B vector minus 6 plus 8 plus 10. Now here we multiply only the corresponding numbers, means only I with I, j with j, and k with k. We do not multiply I with j or j with k or k with j or k with I. We only multiply the two I values, the two j values, and the two k values. So plus 3 into minus 6, that is minus 18, plus 4 into plus 8, that is plus 32, and plus 5 into plus 10 is plus 50. Now note that after multiplying there is no I or I square. 3i into 6i, you think that it should be I square. There is no I square because it is a dot product. So after multiplying there is no direction. When there is no direction, there will be no I, no j, no k. Because I, j, k, they denote the direction. I means along the x-axis, j means along the y-axis, k means along the z-axis. So after multiplying they have become scalar. They have no direction. So there will be no I square, no j square, no k square. In case of dot product, in case of cross product, we will have I square, ij, ik. But here in case of dot product, we multiply the numbers, but do not put any I or I square, do not put j or j square, do not put k or k square. So we get minus 18 plus 32 plus 50. Now these are absolute numbers, no direction. So we can simply add them, minus 18 plus 32 plus 50, which gives you AB equal to 64. This is the dot product value of the two vectors. 64, again no I, no j, no k. There is a scalar quantity, so only a number 64, that is a scalar product or dot product of vectors A and B. Now we come to a very important concept. Now what was the first vector? 3, 4, 5, which can also be written as 3i plus 4j plus 5k, and the absolute magnitude we told you, that is square root of the sum of their squares. So square root of 3 square plus 4 square plus 5 square, which is giving you 5 root 2 units. And the second vector was minus 6, 8, 10, or minus 6i plus 8j plus 10k, and the absolute value of vector B was square root of 6 square plus 8 square plus 10 square, that is 10 root 2. So the product of absolute value of A and absolute value of B will be 5 root 2 multiplied by 10 root 2, 5 into 10 50, root 2 into root 2 2, so it gives you 100. And AB we have already found 64, we have already calculated. So the absolute values, that is absolute value of A multiplied by absolute value of B is 100, and the absolute value of the product AB is 64. Now we have a very important final thing to tell you about the dot product. So now we come to the angle between the vectors. So the product of absolute magnitude of A into absolute magnitude of B was 100, and the value of vector AB, that is a dot product, scalar value of vector AB was 64, right? So the product of the absolute magnitude of A into absolute magnitude of B was 100, and after multiplying vector A into vector B, the dot product, the value was 64. Now cos theta, where theta is the angle between the vectors, cos theta is given by the ratio of these two values, AB by absolute magnitude of A and absolute magnitude of B. So 64 by 100, that is giving you 0.64, right? AB was 64 and the product of the absolute magnitude of A into absolute magnitude of B was 100. So when you divide the cos theta value, we will get 64 by 100, that is 0.64. So the angle will be cos inverse 0.64, that is 50.2 degrees. Of course, this I have got it from the table or calculator. You can't actually say offhand, but this will be 50.2 degrees. You can get either from calculator or from a table. That cos inverse 0.64 will be approximately 50.2 degrees. That will be the angle between vectors. And remember, in dot product we always use cos. In cross product we will use sin. Sin theta we will use in case of cross product and cos theta in case of dot product. So the angle between vectors, that is cos inverse, the ratio was 0.64, so 50.2 degrees. So finally we will summarize what we have learnt. A brief summary which will help you to recapitulate. Vector may be written in two ways. Either you can write as A, B, C, or as AI plus BJ plus CK. The absolute magnitude is given by square root of A square plus B square plus C square. Dot product of two vectors is a scalar quantity. That means after multiplying, it will not have the arrowhead. It will not have any I or J or K associated with the product. So dot product, you will not write IJK, you will not put an arrow. For dot product, proceed thus. Just multiply the corresponding ones. A1 into A2, that is the two I values. B1 into B2, that is the two J values. C1 to C2, that is the K values. After multiplying, do not write I, J or K because they have become scalar. So just add them. And the angle theta is cos inverse the value of the product AB, that is the dot product AB, divided by the product of the absolute magnitudes of A and B. So AB dot product divided by absolute magnitude of A into absolute magnitude of B, that is the cos theta. So cos inverse of this will be angle theta, that is the angle between vectors. So that was a brief summary of what we learned in this video. In next video we will talk about cross product. So thank you and goodbye.